Electric Crew here again. I have another little project that I wanted to talk about on the bench. Another amplifier I built. I've been building these things for around 10 years. I've done a number of them, but not as many as some of the other fellows have. I always have something interesting on the workbench to play with, such as this Jackson tube tester. That'll be another video. As you know, one of the last videos I did was of a Dynaco ST-35 Clone, kind of like my version. I finished that one off, and actually the only change I made to that recently is I was using two 12BH7s for the drivers and a 12AU7 for the preamp tube. But I found out, as many of you probably know, that the 12AU7 isn't a very linear tube, and I put a 12BH7 in the place of that one. Boy, what a nice difference. It sounds a lot better. Anyway, as I always say, if you want to hear something, build it yourself and get an idea of what it might sound like. So I always wondered what a Dynaco ST-35 would sound like. So I endeavored to pull out some old parts I had on the bench and put one together. And this is what I came up with that I wanted to talk about. That's what it looks like. And interesting enough that I did change the circuit a little bit. I'll talk about that. I've used some Heyboer transformers on the output, and boy, I'll tell you what, these are really nice sounding transformers. It's the first time I used Heyboer, and they are nice sounding. I was really surprised on what this little EL84 amp can do, the low power that it is, and how well it sounds compared to some of the others. I mean, I've used different transformers in the past. I've tried Ed cores. I've used actually in the ST-35 Clone. They were some custom wound hammets. I do like the transcendars that I used in a single-ended amp, and actually that originally had some KT77s in it, but I just recently changed that so I could run some KT88s in there, and actually there is a difference. I think it sounds much nicer in trial mode with the KT88s in it. So anyway, let's talk about this particular amplifier and the changes that I made. It's very close to the original ST-35 circuit with some subtle differences. Of course, it's not an ultralinear amp. It's a pentode, but it sounds darn good for a pentode. And it's just on a preference, I guess. Most of the amplifiers that I built were ultralinear amplifiers. And as a matter of fact, that Kit 4 clone that I made, the 6v6, I think at some point, those have Ed cores in them. I'm going to order a couple Heyboers for that. And I'm going to see what, I bet you that'll sound a lot better than them Ed cores. Actually, the Ed cores that are in there are actually what they sell as their replacement for the ST-35s. But I don't think the quality's there, because these Heyboer transformers, boy, they just sound more full. That's all I can explain it. Just sounds better to me. So let's talk about that a little bit. And if you have any questions later on, I might leave some links to some of the schematics in the section down below. And if you have any comments, questions, like I said, I'm no wizard, but you have to be careful when you're building these things because of the high voltages involved. You can get hurt if you're not careful, if you're not paying attention to it. I've been an electrician all my life, so it was always the case. You always keep one hand in your pocket if you can, unless you got the gloves on when you're working with electrical. As the only time that I actually hurt myself, believe it or not, it was on 120 volts, and it was on a piece of equipment where I worked in worked in hospital maintenance, and it was a piece of laundry equipment in the laundry, and I actually forgot there were two power sources in that, and I got 120 volt through both hands, straight across, and it hurt. That's the only time I've got zapped a lot of times on different voltages, but never straight through the chest. So you really have to be careful, especially with the higher voltages in these tube amplifiers, so that you don't hurt yourself, and take a lot of precautions. Make sure the voltage is, double check that the voltage is gone, or that you have the capacitors discharged before you get your hands in there, because it will bite and you can hurt yourself if you're not careful. So this is a close-up. This one was a Hammond case, I do believe. This one's all steel, it's not aluminum. But I went through most of the parts looking for what I could have to build this, and actually I only had to purchase these two output transformers. I had mostly all the other parts handy and a couple odds and ends. This is a dual volume control. Actually, it's the type you would use in a guitar, and it works out nice because it's small and it does the job. EL84s, 12 DW7 for the drivers. We'll talk about that in a little bit. But I want to look at the original ST-35 schematic first. Let's pull that up. Now, the difference between this and the modifications that I made, of course, I used 12 DW7s, and they have a little bit of positive feedback right here, this R4 and C3 that I eliminated. Plus, this is an ultralinear setup with the original Dynaco transformers that they used, and I used pentode. We'll talk about that when we look at the schematic and the way I did it underneath. I added and changed a few things, but all in all, it sounds pretty good. Now you notice they took the feedback off the 16 ohm, which obviously my transformers are 8 and 4, though I just used the 8 ohm tap, so I had to experiment to find the correct feedback size for the resistor and the cap. And they have a little more feedback coming off of this connection that of course I didn't use because I didn't use any ultralinear transformers. So let's look at my schematic. And we'll start up here in the amplifier. Now you notice I don't have the positive feedback here, but I did put this snubber in to snub out any of the high frequency trash that you don't need in the ultrasonic, which sometimes can damage your speakers and also give it a really harsh sound on the high end. And again, the 12 DW7s. Now 12 DW7 is a neat little tube where half of it is 12 AX7 and the other half is 12 AU7. The 12 AU7 makes a nice driver, but for a preamp tube, it's not so great. So this is the 12 AX7 section, and we have 500K potentiometers on here. Basically, the circuit is almost identical except for the changes. I took out the little bit of positive feedback that was in here, and I added this snubber here, and also the snubber across the output transformer. So that also helped. And of course, this one is fixed bias, whereas the original ST-35 had a little bit of different setup. And we have the Heyboer, which are 20 watt, 8K primary, 20 watt output transformers. And I'm getting a nice solid, as I'll show you in a little bit, 12 watts, 10, 12 watts with no distortion on the output here. I'll show you the waveform, the square waves here. And the power supply, I used a musical power supply transformer, some musical power supplies. They basically make a lot of stuff for guitar amplifiers, but I had this one laying around and it worked out. Just your standard diode rectifier. And I have a triad 6 Henry choke in here with, you can see the filter caps. And for the supply for the screens, I have this little circuit here, which is a neat little circuit. I've used it for other things. You can actually take this fixed resistor out and put in a variable resistor, and you can have an adjustable power supply if you want. But it uses this little R8N3 IC chip, and it controls a tip 50 transistor, and it works pretty nice. In this particular resistor, 499K, sets it at 300 volt, which I have on the screens up here. So that works out pretty good, and it works out nice. Like I said, I use this little circuit in other things. I found it on a net one time. I think the fella had used it in the old tube radios where they had the choke supply for the wrapped around these for the speaker coil before they had the good permanent magnets. He had this circuit. He was using it in that instant. But of course, this tap here ran off the 6.3, 3.5 amps for the EL84 outputs. And this transformer seemed to run a little bit high, even though I was using 120 volt tap. There's 115 and 120 volt tap on the input. And so I had to use actually a small resistor in here to keep this voltage level at a good spot, so it didn't put too much high voltage on the output tubes. And a lot of people ask me why I use DC. I just started out doing that, and that's how I wire my preamp tubes. But in this case, you have a preamp and a driver, but just a full wave rectifier, a couple caps, and another resistor to get the voltage on the 12 DW7s where I need it. I'm running them on the 6 volts instead of 12 volts. You can do that just like a 12AX7. You have the capability of doing that. And of course an LED. This is the circuit for the fixed bias. Comes off the 55 volt tap here through a diode cap. I neglected to mark I can't remember what the values of these caps were. Something around 10,000, I'm not sure. I'd have to look up to see what I used. And 6.8K resistor in here. And these are the little variable resistors, those little square potentiometers, as you'll see from when we look at the bottom of the unit, where you can adjust the bias voltage. And I have it set at 23 milliamps idle, and that seems to really sound pretty good. I actually experimented around with some different bias settings here, and at a higher bias setting, it actually doesn't sound as good. It seemed like for this particular setup, when I got up to around 28 milliamps, it was starting to throw some distortion off, which was weird, but it really sounds good at 23 milliamps at idle. So let's take a look here at the let's see what I think I have somewhere. That's the square wave. Wait a minute, here we go. Now the these turret boards, actually I had one long board. Both of these were together. One day, years and years ago, I decided to build a Muller 520 stereo, and I had laid this out and had these boards. You can have these made over at Hoffman Amplifiers, and they have a neat little piece of software that you can lay your board out first, and it'll calculate by the number of holes and size and cost. You can lay it out. I laid it out on a piece of graph paper to how I wanted to do it. But I had this here, so I cut it in half, and I inserted the eyelets and posts where I need them for this, and just used it because I had it there. So that's about simple as that. The power supply section over here, and this is that that transistor to regulate the 300 volts on the screens, and can't see it very well, but right here is that little IC transistor, and your resistors to set the voltage. A couple caps there for the DC on these two preamp driver tubes, and this was the little board that I had for the set the bias, so you could set each individual tube with the bias. And here's a dropping resistor I had to use for the filament for these EL84s, and there's the cap and the resistor snubber across the each output transformer. And I think I used the CL60 in here on the input of the AC. Gives it a little bit of a slower warm-up. I think these are 16 ohms cold, and it drops as it warms up. So, all in all, it worked out good. My version of the ST-35, and it sounds good. So if the original sounded every bit as good, and it is really dependent a lot on the transformers, and I heard those were original transformers that came in the ST-35s were supposed to be pretty quality transformers. So we'll back here and look at the waveform. This is a square wave at of course this is 9.14 volts, so that would be 9.14 watts at 10,000 hertz, and it's a pretty good square wave, so I'm not getting any ringing or too much garbage in there. So that was a nice little project, and a nice sounding project that I'm impressed with those Heyboer transformers, I'll tell you that. So if you have any questions or any comments, feel free to give a yell. So other than that, have a good day.